So let's take a look at number 1. We need to rewrite each polynomial in standard form, name each polynomial by degree and number of terms. So is this in standard form for number 1? Yep, there's only one term, so it's already in standard form. How do we classify it by degree? What's the highest degree? 3. And what do we call something with the highest degree of 3? Cubic. Awesome. A lot of people on the quiz just put 3, but what I'm looking for is that word cubic. Next, we need to classify it by the number of terms. How many terms is there? 1. So what do we call something with 1 term? Monomial. Awesome. So again, looking for this word, monomial. All right, let's look at number 3. How do we put this in standard form? What goes first? Negative 9x to the 5th power, because that's the one with the highest degree. What comes next? Negative 2x to the 2nd power. And then what? Plus 9x. And then what's last? Plus 5. Perfect. So how would we classify this by degree? What's our highest degree we have here? 5, and we call that quintic. So you have to know that the highest degree is 5, but you need to answer it with that word quintic. That's the answer. Classifying it by degree needs to have this word here, quintic. What about the number of terms? How many terms do we have? 4 terms. And what do we call something with 4 terms? Polynomial of 4 terms, or with 4 terms. So anything higher than 3 doesn't have a specific name. It's just polynomial with however many terms. So if we had something with 5 terms, it would be a polynomial with 5 terms. For these types of questions, make sure you put it in standard form first, because sometimes a term could repeat. Like if you had 2x squared terms, you combine those to 1, so then that changes how many terms you have. So you have to put it in standard form, even if the question doesn't ask for it. But when naming it by degree, you're not just looking at the first term. You have to put it in standard form, and then name it by degree, and then name it by the number of terms. A lot of people made that error on the quiz. So you have to put it in standard form first, and then look at your highest degree and the number of terms. So even if it doesn't ask for it in standard form, you may need to put it in standard form to then classify it by degree and number of terms. All right, describe the end behavior of each polynomial. So just like before, we don't have to put it all into standard form, but we need to look for the highest degree. So if it's not in standard form, we're looking for the term with the highest degree. So which term here tells us about the end behavior? What are we looking at here? For number 5. Awesome, x to the 6th power, that's our highest degree. So is x to the 6th power positive or negative? Positive. So what does that tell us about our right arrow? Right arrow goes up. And then is 6 even or odd? 6 is even. So does that tell us they go in the same direction or opposite directions? Same direction. So the left arrow goes which way? Same way. Up also. So we have up and up. So in words, this would be up and up. Number 7, which term are we looking at? X to the 9th power, because that's our highest degree. Is this positive or negative? Positive. So what does that tell us about our right arrow? Right arrow goes up. And then is it even or odd? Odd. So they go in the same direction or opposite directions? Opposite directions. So what's the left arrow going to do? Down. So we have down and then up. So remember, the order matters. Alright, next. We've defined all zeros and graph. So how do we find all the zeros? X equals 0, so we just set each piece equal to 0. So we said x equals 0. What's our next piece?
X minus 2 equals 0.
Negative x plus 2 is equal to 0.
But when we just turn to x minus 2 equals 0?
Yes. But we're just writing exactly how it is here. And then we can solve it. And then we have negative x minus 5 is equal to 0. So x is equal to 0 is already solved for us. X is equal to 0. Don't have to do anything there. How do we solve negative x plus 2 is equal to 0? What should we do? We can subtract 2 on both sides. So we have negative x is equal to negative 2. How can we get rid of that negative in front of the x? Divide both sides by negative 1. So what is negative 2 divided by negative 1? Positive 2. And then in the third equation, how do we solve for x? Add 5. So we can either add 5 or add x. Either way works. Let's add 5. So we have negative x is equal to 5. How do we get x to be positive? Divide by negative 1. So x is equal to, what's 5 divided by negative 1? Negative 5. Perfect. Now we just need to put all 3 of these points on our graph. I didn't leave much room for a graph. I'll put it up here. So I'm going to stay at 0 and put a point there. X is equal to 2, so I go to the right 2. And x is equal to negative 5, so I go to the left to negative 5. So these are my 3 points. Now I need to figure out what my end behavior is doing. How many x's do I have in this equation here? 3. 3 x's. So this is an x cubed graph. Do any of them have a negative in front of the x?
Yeah.
Yep. We have 2 with a negative in front of the x. But what do 2 negatives make? A positive. So this is a positive x cubed graph. So if it's positive, what's our right arrow going to do? Our right arrow goes up. And if is 3 even or odd? Odd. So if it's odd, do they go in the same direction or opposite directions? So what's our left arrow going to do? Left arrow goes down. So our left arrow goes out of the point farthest to the left. Our right arrow goes out of the point farthest to the right. And then what do we do in the middle? Connect the dots. Next page. Let's look at number 12. We have to factor the sum of cubes. So first thing we need to know is our sum of cubes formula. So that is a plus b times a squared minus ab plus b squared. So you guys want to have this formula in front of you for the test. On your little sheet of notes, make sure you have this. This is your sum of cubes formula. So now we need to figure out what our a is and what our b is. So if a cubed is equal to our first term, which is x cubed, what's a equal to? X. Awesome. And if b cubed is equal to 8, what's b equal to? So what number cubed gives us 8? 2. Awesome. So if you don't remember your perfect cubes, make sure you take a look at that common cubes page from your notes. So now we just plug everything into our formula. We have a plus b, so what would a plus b be? How would we write that? X plus 2. Awesome. And then we have a squared. How would we write a squared? X to the second power. Then minus a times b. X times 2, but we would write that with the number first, so 2x. And then plus b squared. So how do we write b squared? What's 2 to the second power? 4. Awesome. 4. So this is our answer. Any questions here? All right, I'm going to save 13 and 14 for tomorrow, so let's look at 15. This is our difference of cubes. So whenever you're subtracting two perfect cubes, you have to use your difference of cubes formula, which is a minus b times a squared plus a times b plus b squared. So it's the same thing, just our signs are different, so be careful. All right, got to do the same thing. Let's figure out what our a is and what our b is. So if a cubed is 64, what is a? So a is equal to 4. And if b cubed is equal to 125x cubed, what's b equal to? Five, and then what about that x? 5x. So then we have to write it a minus b. So how do we write a minus b? 4 minus 5x. And then a squared?
Four squared.
What's 4 squared? 16. And then a plus b? A times b. A times b. How do we write a times b? 20x. Because it's 4 times 5x. So we multiply the numbers, but just leave the x. And then plus b squared. So we have 5x squared. How do we write that?
25x.
Awesome. 25x squared. Because the 5 gets squared and the x gets squared. So this would be 25x squared. And that's our answer. Any questions here? So for these, you're not solving. All we have to do is factor. Just put it into your formula, and that's it. Nothing more. All right, we're going to save 16 and 17 for tomorrow, so let's look at 18. Factor by grouping. So to factor by grouping, we start by grouping the first two terms and then the second two terms. So we have our first two and our second two. What do we have in common in our first two terms? Awesome, x to the second power. So if we take out x to the second power, we're dividing both of these by x squared. What are we left with? Awesome, x minus 3. So if we had 3 x's and we took 2 away, we're just left with 1, and then here our x squareds cancel out. What can we take out of our second group? 4. So we're dividing both of these by 4. So what are we left with? X minus 3. So then, what do we do next? Are the parentheses the same?
Yeah.
So we know we pulled out the right numbers because our parentheses are the same. What can we do next?
You put x squared plus 4 in parentheses and then x minus 3.
Awesome. X squared plus 4 and then x minus 3.